Hello everyone, welcome to today's webinar. Today we will focus our study on fractions. Today we will go over the most challenging topics in this lesson, and also we will have a good chance to practice together some of the problems. Before I go ahead and start my webinar, I want to say that today with us today in the webinar, Laura Racine is attending, and she will be helping you with your general questions. If you have any general questions during our presentation, you're able to post them in the questions box, and Laura will answer them for you. If you have a math question that deals with what we're going to talk about today on fractions, then I will answer that myself. And the raise your hand feature is not available in our webinars. This is myself. I'm the math instructor at Penn. I have been with Penn since 2015, and I'm so glad that I'll be here today to offer help in that challenging topic. So today's webinar objectives is really to focus on the major topics that I hear on calls, emails, and chats about fractions. The most ones that I get from students are the ones that I chose to be the topics of my webinar today. So hopefully by the end of this webinar, you feel more confident to work with fractions. Let's start right on the task. So adding fractions is an easy task if you have the numbers on the denominators are the same. So we know what to do in that case. We just add the numerators, which are the numbers on the top, and keep the denominators the same. But the problem comes, or the problem become more challenging if we have different numbers in the denominator. I'm going to mention what we should not do, and then I'm going to show you how to add these two mixed numbers with two unlike denominators. We should not add 1 and 2, 1 and 2, and 2 and 5. This is the wrong way to do it. The right way to do it is to find an equal fraction of 1 over 2 and an equal fraction of 2 over 5 such that these two equal fractions will have the same number in the denominators. When we do that process, we're not going to touch the whole number 2, or the whole number 1. We're just going to change those fractions. Now, the next question that you may be thinking of, how? How are we going to change those two fractions to other two equal fractions and have the same number on the bottom of each fraction? Here, in that process, we need to use the least common multiple. The least common multiple is mentioned in your lesson as LCM. And what that basically means is that you get each of the denominators, 2 and 5, list all the multiples, and that's why we call it the least common multiple. List all the multiples of 2. And we know how to do that from elementary school. What are the multiples of 2? 2, 4, 6, 8, 10, and so on. 5, that would be 5, 10, 15, 20, so on. How to determine which one is the least common multiple? That would be the number that you see common between the two lists, and it's the least of all of the common ones. The least common multiple is 10. And that will become also our new denominator, which we call in the lesson the least common denominator, LCD. So 10 will become our new denominator. How can we change then the fractions to fractions with a 10 in the denominator? That will be done by asking ourselves a question: how can I change the 2 to 10? Multiply times 5. And if you multiply denominator of a fraction times 5, you have to do the same thing on the top times 5. That will make us change the fraction part of this mixed number to an equal mixed number. So the 1 will stay the same. 1 times 5 is 5 on the top. 2 times 5 is 10. And now we have the 10 in the denominator. Plus, we're still adding. How can I get the 5 to become a 10? Because 10, remember, is our LCD. Multiply 5 times 2. You have to do the same thing on the top, times 2. The 2 whole number will be the same. 2 times 2 is 4 on the top, and 5 times 2 is 10 on the bottom. Now we have two mixed numbers. The fraction parts of each have 10 in the denominator. From here, it gets too easy. I'm just going to add the whole number parts. 1 plus 2 is 3. 5 and 4 is 9. And keep the common denominator as is. The final answer is 3 and 9/10. Questions about how we did find the denominator, the common denominator, and how we added. If you have questions, if you just joined us, you can type your questions in the questions box. Okay, the next problem is similar. So we're having a 9 and a 3. We cannot add. We have to change the problem first. By time, with practice, you will not have to list the multiples of each denominator. It will become a second nature. You will just notice that 9 is a multiple of 3. So you will have to keep the first fraction is the same, because 3 you can easily change to 9. And in this case, 9 will become your common denominator. 3 times what will give you 9? 3 times 3. So times 3 and times 3. Do we have to change the first fraction? No. Is it the rule that you have to change both fractions like the first problem? No. It depends on the numbers that you have in the denominator. In the first question, yes, we had to change both fractions. In the second question, no, we did not have to change both fractions, only one. So the problem becomes 3 and 2/9 because we did not change that number, plus 1 will stay the same. 1 times 3 on the top is 3. 3 times 3 on the bottom is 9. Now we have two fractions in those two mixed numbers with the same denominator, and then we can apply the rule of addition for fractions. 3 and 1 is 4. 2 and 3 is 5. And 9 will remain in the denominator. The answer is 4 and 5/9. Questions? Throughout my slides, you will notice that I have those circles with notes. These are just a summary of the steps that we use in each kind of problems. So if you want to write them somewhere on your notes, keep them handy. You can borrow them and just keep them whenever you're not sure what's the next step. You can just look at your notes, and hopefully that will help you. Now, this problem is a self-check problem. What that means is this is a problem that you will get to work on it before I go over it with you. So this is a chance for you to practice. What's going to happen, I'm going to leave you look at the question on the screen. You have 4 answers. One of them only is the right sum of these two fractions. And then after like a minute or so, I'm going to change my screen to the same question, but this time you'll be able to enter or submit your answers. So we have been adding mixed numbers with different denominators. This question is the same story. We have two fractions. One is a fraction, is not a mixed number, but that will not make us change the rules. The other one is a mixed number, but both fractions does not have the same denominator. What should we do to find the sum of 3/10 plus 4 and 3/5? Take your time, write down the problem on paper, and think about how can we change both denominators to the same number. Are we going to change both fractions or one fraction only? I'm just waiting for everyone to write down the problem, think about the problem, start to take steps to find the sum, decide on what would be the common denominator. Do you see anything that catch your eyes? 10 and 5. What do you think? What would be the common denominator? Okay, I'm going to change my screen now. So it gives you the same exact questions with the same answer that you see on the screen, just with a chance to submit your answers. And here you go. I have answers coming in already, so that is a good sign. If you are able to add fractions or mixed numbers with different denominators, that is a good sign that you will be able to subtract, write, and multiply and divide correctly, because addition and subtraction is the most difficult ones, because these have to have the same denominators. If that's pretty easy for you, that means that you eventually will get multiplication and division. A few more seconds and then we can go over the problem together so everyone is clear on how we got the answer. Okay, let's do the question together. So again, 10 and 5, it clicks something on my mind. 10 and 5. Well, 10 is a multiple of 5. I don't have to change the first fraction. 5 can be easily changed to 10 by simply multiplying the denominator times 2 and the numerator times 2. So I will have 3 over 10 plus 4 is not changed, 6 over 10. And from there, I can just add nothing plus 4 is 4. 10 will remain as is in the denominator. 3 and 6 would be 9. So the answer is 4 and 9/10, and the answer is C. And everyone got this question correctly. Good job. Okay, next, subtraction. Subtraction is a little bit tricky because some subtraction problems, we can just subtract by changing the denominators and subtract the numerators and the whole number parts, and that's it. But some other problems, like number B, you have to borrow. And we're going to go over in details on how can we borrow if we have to in a subtraction problem. With addition, you will never have to borrow. With subtractions, you may have to borrow. So let's go over the first question. 4 and 3/5 minus 2 and 1/3. Again, 5 and 3 are not the same number, so we have to find the least common multiple or the least common denominator. In our head, if we list the multiples of 5 and 3, you will know that 15 is the least common multiple that we can also use as the common denominator. Times 3 to become 15, and we have to do the same thing on the top, times 3. 4 will not be multiplied times 3. For the 3 to become 15, it has to be multiplied times 5, and 1 has to be multiplied times 5. Let's rewrite the problem. We have 4, 3 times 3 is 9, 5 times 3 is 15, minus 2 is as is, 1 times 5 is 5, over 3 times 5 is 15. Okay, let's try to subtract and see if there are any problems. Well, 4 minus 2, yes, we can do that. 9 minus 5, yes, we can do that. So this is a sign that this problem is a no borrow problem. This problem can be done by simply subtracting 4 minus 2 is 2, 15 will stay as is, 9 minus 5 is 4, and that would be your final answer. And we did not have to borrow in this problem because the first numerator is greater than the second numerator. So we were able to take 5 away from 9. On those cases that we have to borrow, you will find that the numerator in the first fraction is smaller than the second one. In this case, it's a sign for you that you have to go ahead and borrow, like number B. Before I go into B, anyone has a question on number A? Okay, let's do number B and take it so slowly that we absorb how can we do the borrowing method. So First of all, we cannot decide if we have to borrow or no just with those denominators being not the same. We have to find the common denominators first and then see if we have to borrow or no. I have 21 and 3. Does it bring up anything in your mind about 21 and 3? Isn't that 21 a multiple of 3? Yes. So in this case, we're not going to change the first fraction, only the second fraction. 3 times what equals to 21? Times 7. So 3 times 7 and 3 times 7. Rewrite the problem. We have 6 and 10 over 21 unchanged minus 2 times 7 is 14 and 3 times 7 is 21. And that looks good because both fractions now have 21. Next, let's try to subtract. 6 minus nothing, that's no problem. 10 minus 14. Can we take away 14 from 10? No. And this is where you realize that you have to borrow. How can we borrow? From where? We usually borrow from the whole number from the first mixed number. So we are able to borrow 1 from the 6. If the 6 will give us a 1 to use, then the 6 will become a 5. And then the 1 that we borrowed, we need to rewrite it as a fraction. Isn't that 21 over 21 is a 1? Yes, this is the borrowed 1 that we did take away from the 6. Now we have that 1 to add to the original fraction part of our mixed number. So 21 over 21, which is the 1 we borrowed, plus the 10 over 21. These two fractions belong to the 5. Anyone does not understand how we did the borrowing in this step? If you do not, you can write something on the questions, and I'm going to go over it again if you'd like. Okay, so subtracting, and 14 over 21 is the same. Now we have two fractions here to add. And thankfully, the 21 is the common denominator. So we will end up having 5. 21 and 10 is 31 on the top. 21 is the same. On the bottom, we just apply the rules of adding, nothing new. Minus, we'll start subtracting, and then 14 over 21. Now, let's try and check. 5 minus nothing, yes, it will go through. 31 minus 14, yes, we can do that now. 31 minus 14 is 17 on the top. You have 21 on the bottom. 5 minus nothing is a 5, and that would be your final answer. Questions? Anything that was not clear on why we borrowed or how we borrowed? Okay, that's a good sign. Let's move on to a practice problem. 3 and 5 over 12 minus half. It's a subtraction problem. So we have different denominators. We have to figure out what would be the common denominator first and then decide if we have to borrow or that's a simple subtraction problem. I'll leave you with that question. Take a minute or so, write down the problem, work on the common denominator, find it, rewrite your problem, and then decide. Okay, I'm going to change my screen to give you the same problem. Here you go. 3 and 5 over 12 minus half. What would be the common denominator? What do you think? 12 is a multiple of 2. Would that mean that we have to change both fractions or only one fraction? Waiting for everyone to finish the problem. Take your time. A few more seconds and we can do the problem together. I still have answers coming in, so I'm gonna allow like 10 more seconds for everyone to have a chance to participate. And this is the whole idea about live webinars. I could have recorded that and just post it somewhere, but I really like the interaction. I really like the opportunity for you to ask questions, to submit your answers. That really makes a difference. When I personally give instructions, I feel like actual people are listening and they're maybe taking notes, maybe thinking with me on the problem. So that makes it more enjoyable at my end. Okay, let's do the problem together. So subtraction, different denominators, we cannot subtract like that. We have to decide on a common denominator. I'm repeating myself just because the self-talk sometimes when you repeat it in your head over and over again, it just becomes a second nature after a while. So 12 and 2, well, 12 is a multiple of 2, so we can easily switch 2 to 12 by multiplying times 6 and multiplying times 6. So our problem will become 3 and 5 over 12 unchanged minus 6 over 12. The first goal I have already done, 12 on both fractions. Now, 5 minus 6 on the numerators would not work. We have to borrow. This is a borrowing question. We borrow from the 3. 3 will give us a 1. So 3 will go down to a 2. And that 1 that the 3 gave us to help us on the numerator problem will become a 12 over 12. That's the 1 I borrowed. But I cannot forget the original fraction, plus 5 over 12. Still subtracting 6 over 12. So 2 will have a fraction part of the 12 will become the same in the denominator. Again, we're applying the rules of adding. 12 and 5 will be 17. We're still subtracting minus 6 over 12. Now let's try it again. 17 minus 6. Yes, we are able to do that. So it's 11 on the numerator, 12 in the denominator, 2 minus nothing, just the same 2. So your answer is A, 2 and 11 over 12. And everyone got that answer correct. Good job. Okay, let's move on to the next topic in this lesson, multiplying mixed numbers. Okay, so with multiplication and division, it's a little bit easier because we do not have to have the same denominators. We actually are able to perform multiplication and division without having the same denominators. That's good. The other thing that we have to worry about is we need to simplify the problem before we actually multiply the numerators and the denominators. And why is that? Because if you do not simplify the problem before you actually multiply and find your product, you will eventually have to simplify your answer, and that simplification process will be ambiguous, if I want to use that word, because you did multiply a bunch of numbers that are not simplified at all. You came up with a really not simplified answer. So the easier way to multiply is to simplify the numbers before you multiply, and then you multiply the simplified numbers that will give you the simplest answer. That will be the least amount of work that you will do in a multiplication problem. How can we do that? In our lesson, they talk about cancellation method. What they mean by that is we need to find a number from the top and a number from the bottom where those two numbers have something in common. For example, there is a common factor between 8 and 2. We know that both are even numbers. then 2 would be a common factor. We need to eliminate that common factor. How can we do that? Divide. Take away that factor, divide over 2, and divide over 2. And I chose 2 because this is the only common factor between 2 and 8. Rewrite the problem. 3 is as is. We did not divide over 2 for the 3. 8 divided by 2 is 4 times 2 over itself is a 1, and then you have a 5, the bottom unchanged. Okay, and we still have the, if I just want to take away that 2 for now, just to make it simpler, that would be helpful. So if I have these two fractions without the 2, I would do it that way. 3 over 8 multiplied times 2 over 5. I want to simplify my problem first. Divide over 2, rewrite the problem, 3 over 4 times 1 over 5. Now, can we find any other common factors between a number on the top and a number on the bottom? Let's check. 3 and 4, nothing in common. 1 and 4, nothing. 3 and 5, nothing. And 1 and 5, nothing. I mean, 1 and any number, there is a common factor, which is 1. 1 is not helpful. We want to find a common factor that's not a 1, like a 2, 3, 5, 10, 100. So for this problem, this is the simplest way. Just multiply across. 3 times 1 is 3. And then 4 times 5 would be 9. I see 3 and 9. We can simplify the answer more. Divide over 3 and divide over 3, and that will give you 1 over 3. And that would be the product of these two fractions. Okay, questions? Anything that was not clear on why we have used the cancellation method and how? Okay. Well, 4 times 5, I'm sorry, I'm just adding right now, 4 times 5 is 20. And this is where the numbers did not click with me. It was like something is wrong in this multiplication question. And this is what I like with experience when you practice a lot. When you multiply two numbers and the answer doesn't make sense, I just checked it now because I felt something is wrong, and there was something wrong because 4 times 5 is 20. And that would make more sense. So we have 3 times 1 is 3 on the top, and then 4 times 5 is 20 on the bottom. So if we do the 3 over 20, and that would make sense with the answer. So your answer actually is 3 over 20, and that is not addition. So your answer is 3 over 20. Questions? Okay. Would you like another example to work on it together so you're able to make sure that we have the right steps, because I did add instead of multiplication here. If you want another example, an extra example, let me know on the questions. You can write yes or please, so I can just make up one and work on it. Okay, everyone is fine with that? Okay, now what if we had the 2 in front of the fraction, because multiplying mixed numbers is different a little bit than multiplying just mere fractions. So if we have the 2 and 3 over 8, and then we have to multiply times 2 over 5, then we were not able to use the cancellation method right away like we did in this question, where the 3 over 8 was just a fraction with no whole number part. So if we are multiplying two fractions, one of them at least is a mixed number, then we have to change the mixed number to an improper fraction. And from your study of this lesson, you remember to change the mixed number to an improper fraction by multiplying 2 times 8 and then plus 3. So 2 times 8 is, and then plus 3. So if you multiply and add, that would be 19 over 8, and then times 2 over 5. 2 over 5 is not changed again because it's not a mixed number, but if we're multiplying this mixed number times that fraction, the mixed number has to be changed first. Once we have this step there, you look at it and they are only fractions with no mixed numbers, then we're just going to repeat what we just did with the other question, the first question here, which is basically applying the cancellation method. And again, 2 and 5, 2 and 8 are numbers with common factors. Divide over 2 and divide over 2. 19 over 4 times 2 over 2 is a 1 over 5. Multiply 19 times 1 is 19, and then 4 times 5 is 20. So that would be the final answer for this question if we had the mixed number in. So the main idea to keep in mind is when you have a mixed number in division or multiplication, you have to change it first to an improper fraction, use the cancellation method next, and then multiply across. Okay, so if you have the slides printed out already, I did go over 2 different questions in this slide. One with no mixed number, 3 over 8 times 2 over 5, and the other one is the one that you have in your printouts, the 2 and 3 over 8 times 2 over 5, and obviously the two problems have different answers. Any questions on how to do the cancellation method? Okay, let's go on to a practice problem. The same thing. 1 and 4 over 7, that's a mixed number, times 21 over 44, that's a fraction. What should we do to multiply a mixed number times a fraction? Can we use the cancellation method right away, or we have to rewrite the problem first? What do you think? Write down the question if you don't have the slides ahead of time, and think about the first step that you need to take. Okay, here's the question again. And this time you're able to submit your answers. What would be the product of multiplying 1 and 4/7 times 21 over 44? It's the end of the day, so it's hard to do math maybe at the end of the day. So, okay, so I have answers in, and so far the answers are correct. So if you did start the problem already, I want to give a hint to whom they're still thinking about the first step. We need to change the mixed number to an improper fraction first and then apply the cancellation method if possible. Sometimes you cannot find any common factors, then you will have to just multiply across right away. What would be the product for these two fractions? Okay, let's do the question together. I'm going to remember to multiply, not to add. So we have 1 and 4/7 times 21 over 44. We cannot do anything yet. We have to change to an improper fraction. How? Multiply 1 times 7 is 7 plus 4 is 11, and keep the denominator as is. 7 times the second one is just a fraction. Write it as is. Now check, do we have any common factors we can eliminate from our problem? Yes, I see 21 and 7. If I divide over 7 and divide over 7, that will change the problem to 11 over 1 times 3 over 44. But wait, we have 11 on the top and 44 on the bottom. Then, yes, exactly. 11 is a common factor. So divide over 11 and divide over 11. 11 over itself, it's a 1 over 1 times 3 over 4. Multiply across, 1 times 3 is 3, 1 times 4 is 4, and that is the product, and the answer is D, and good job for everyone. Questions before we leave multiplication? Okay, we did multiply times a mixed number, but now we're going to multiply times a whole number. What should we do? If we have a mix-up, we have a mixed number and a whole number, we're not used to it. So what can we do to start out the problem? The first thing, we need to change both numbers. 6 cannot just stay as a 6. You can rewrite 6 as a whole number in terms of fractions. And you know any whole number is really that same number over 1, and here's the fraction form. That's it. Times, it's a mixed number. We cannot work on that, so we have to change it to an improper fraction. How? Multiply. 1 times 18 is 18 plus 5. That will give you 23 on the bottom. 18 will stay as is in the denominator. Next, since we have fractions, no whole numbers, no mixed numbers, we can use the cancellation method. 1 and 23, no common factors. 1 and 6, no. 6 and 18, yes, so divide over 6 and divide over 6, and 6 over 6 is 1, and you have a 1 already in the denominator. 23 will just stay as is, and then you divide 18 over 6, and that will give you 3 in the denominator. Now, the problem is much simpler. Nothing to be eliminated further than multiply across. 1 times 23 is 23, and 1 times 3 is 3. Now, when you have an answer with an improper fraction, this is not in simplest form. The simplest form is to bring it back to be a mixed number. So I want to remind you how we did that. If you have an improper fraction, how can you change it to a mixed number? And this is how we do it. We ask ourselves, how many times 3 goes into 23? So think about the multiples of 3 and what number you can get so close to 23. If you're not sure, you can use a calculator if you can. You can divide 23 divided by 3 and hit the equal sign. It will give you a whole number and a bunch of decimals. Ignore the decimals and take that whole number part. 3 goes 7 times into 23. So 7 would be the whole number part of the mixed number. 3 will remain in the denominator unchanged. Now we need to figure out the remainder. We do that by multiplying. 7 times 3 is 21. Subtract the old numerator minus that product. 23 minus 21 is 2. Exactly. So the simplest form of this answer, I mean, this is correct. There's nothing wrong with it. But sometimes in the exam or in the lesson, they stress on changing the improper answer to a mixed number. So that would be the final answer, 7 2/3. Questions? Okay, let's go to a self-check. 6 times 1 and 3/10. What do you think? What should we do to prepare our question and to multiply properly? We have a whole number times a mixed number. Take your time, think about it. And here's the question so you can share your answers. Waiting for everyone to participate and submit their answers. What should we do before we use the cancellation method? Okay, let's do the problem together so everyone is sure. A whole number times a mixed number, cannot do the cancellation method yet. 6 over 1 is the fraction form of 6 times. We change the mixed number to an improper fraction. 1 times 10 is 10 plus 3 is 13 on the top. 10 will remain in the denominator. Now we have two fractions, no whole numbers and no mixed numbers. We are ready then to use the cancellation method. I have two even numbers, 6 and 10. Then for sure 2 is a common factor. Divide over 2 and divide over 2. 6 over 2 is 3 over 1 times 13 remain the same. 10 over 2 is a 5. Nothing else can be eliminated. Then we are able to just go ahead and multiply across 3 times 13 will give you 39. 1 times 5 is 5. It's an improper answer, so we're able to change that to a mixed number. How many times 5 goes into 39? 7 times, because 7 times 5 is 35, and you have 39. This is as close as you can get to 39. 5 will remain in the denominator. 7 times 5 again is 35. Subtract 39 minus 35, and that is the difference here. The remainder would be the numerator. So the answer is 7 and 4/5. And everyone got the answer correct. Good job. Now, division. Division is so similar to multiplication. You don't have to have common denominators. We will eventually use the cancellation method, but before we use the cancellation method, we need to rewrite our problem a certain way. So as with multiplication, I see a mixed number in our problem. We cannot do any steps before we change the mixed numbers to an improper fraction. Again, 2 times 5 is 10 plus 1 is 11. 11 over 5, and then we still dividing over 5 over 2. Now, division with fractions is essentially multiplication. The way we want to think about that is when you divide two fractions, it's the same as multiplying times the reciprocal of the second fraction. What do I mean by that? The method we're going to use is we're going to keep the first fraction as is, 11 over 5, change the sign of division to multiplication, and flip the second fraction. It was a 5 over 2. It will become a 2 over 5. Anyone is not clear about how I changed that problem to multiplication? Okay, so I'm going to repeat that again because this is a key concept when we divide. So we had to do the normal steps, change the mixed number to an improper fraction. We understand that. Then once we have two fractions, no mixed numbers, no whole numbers, then we are able to change the problem from division to multiplication. Keep the first fraction as is, change the sign to multiplication, flip the second fraction, find the reciprocal of the second fraction, so it becomes 2 over 5. Now we just treat it as a normal multiplication problem. So we try to eliminate any kind of common factors. I do not see anything common between 11 and 5, nothing. 2 and 5, nothing. 11 and 5, nothing. And 2 and 5, no common factors. Then we just have to multiply across. 11 times 2 is 22. 5 times 5 is 25. And that would be your final answer. This is the quotient of these two fractions. Questions? Okay, here is in the box down there. I just have this in red because this is a common mistake and I wanted to bring it up to your attention. Some students I did talk to, they would use the cancellation method before even changing the problem to multiplication. They would use it in that step. They would eliminate 5 with 5, which is incorrect. Cancellation methods will only be used when you have the multiplication problem. With division, we do not use the cancellation method. So I just wanted to make sure everyone is clear on that. Next is a self-check question. 2 and 1/3 divided by 1 and 4/9. Two mixed numbers, we have division. What should we do to prepare the problem? Take your time and follow the steps to find the quotient. Okay, here is the question. Again, and you're able to share your answer. What is the quotient of dividing 2 and 1/3 divided by 1 and 4/9? Both are mixed numbers. We have division, and we remember that we cannot use the mixed numbers as is. We have to change them to improper fractions. And also, after doing that, we have to change the problem itself to multiplication using the reciprocal of the second fraction. Then specify any kind of common factors between a numerator and a denominator, eliminated, and then multiply across, and you'll have your final answer. A few more seconds, and we'll go over the question together. Okay, let's do it together and see how can we divide the two mixed numbers. Okay, we have to change the first one to an improper fraction. 2 times 3 is 6 plus 1 is 7. So we have 7 over 3, and then we're still dividing. The second mixed number have to be changed. 1 times 9 is 9 plus 4 is 13 on the top, and 9 will remain as is in the bottom. Now we can use the reciprocal method to change this problem to multiplication. We have 7 over 3 times 9 over 13. I see 9 and 3. There is a common factor, 3, eliminated by dividing over it on top and bottom. So you have 7 over 1 times 3 over 13. Look again, 7 and 1, nothing. 7 and 13, nothing. 3 and 1, no. 3 and 13, nothing. Then we're ready to multiply across. 7 times 3 is 21. And 1 times 13, of course, is 13. That is an improper fraction. It is best to change it to a mixed number. How many times 13 goes into 21? Once. 13 will remain as is, and then the remainder is 8. And the answer is B, and everyone did answer this correct. Questions? Okay, let's move on to dividing when the problem involves a whole number. Again, it's the same rule that we had seen with multiplication. We cannot divide like that. Change 15 to the fraction form, so it's going to be 15 over 1. We're still dividing. Change that mixed number to an improper fraction. 2 times 4 is 8 plus 1 is 9. The top and 4 will remain as is. Now we have two fractions. Apply the reciprocal method. 15 over 1 will stay the same, times, flip the second fraction, 4 over 9. Check to see if you have any common factors. I see 15 and 9. Yes, 3 is a common factor, so eliminate the 3. 15 over 3 is a 5. Still have a 1 on the bottom, times 4 stays as is. 9 over 3 is a 3. Check again, nothing more. Multiply across. This is an improper fraction. Change it to a mixed number. How many times 3 goes into 20? 6 times. 3 remains in the denominator. 6 times 3. And then subtract 20 minus the product. That will be 2 on the top. So your answer in simplest form, 6 and 2/3. Questions? We're repeating ourselves. We're just doing the same steps all over again. So once you just look at the problem, you will, in your head, you will have a plan on how to proceed to find the quotient, the product, the sum, the difference, and so on. Self-check question. It's going to ask the same thing, a whole number divided by a fraction. There is no mixed number. What should we do to find the quotient? And here is the question. What would be the quotient for 6 over 24 over 50? Which one is the right answer? Okay, let's go over the problem together. A few more seconds. I just want everyone to put their answers through. Okay, again, we're repeating the same steps. We have 6 over 24 over 50. I'm going to prepare this problem in one step. Just change the 6 to 6 over 1 to be a fraction divided by 24 over 50. Now we change the problem to multiplication. You have 6 over 1 times 50 over 24. Now check for any common factors. We have 6 and 24. Yes, divide over 6 and divide over 6. 1 over 1 times you have 50 over 4. Two even numbers. Yes, there is more factors to eliminate. This time it's a 2, divide over 2 and divide over 2. So you have 1 over 1 times 25 over 2. Multiply across. 1 times 25 is 25 over 2. This is an improper fraction. Change it to a mixed number just to put your answer in simplest form. How many times 2 goes into 25? 12, because 12 times 2 is 24. So 12 times 2 remains in the denominator. 12 times 2 is a 24. Subtract 25 minus 24 is a 1. Your answer is 12 and a half. 12 and a half is the answer. Questions? Anything that was not clear throughout the webinar? Anything that you wanted to see or you wanted to double check on how we do. Okay, if you have any general questions, that is the right time to ask them on the questions box. If you're not sure about your program or not sure about some lessons in this course, I'm just waiting for your questions if you have any. Okay, well, it's a good sign. So if you still have questions right after the webinar, my email address is going to be sent out in the follow-up email when you get the recording of this webinar. So if you have questions, don't hesitate to email. I want to thank everyone who did attend and participate in this webinar. There is a small survey that will just show how we did do in this webinar. Just share your opinions and share what kind of improvements that you would like to see in future webinars. And if you have any topics that you want to suggest for future webinars, you can email me and just ask me to do a webinar on that one lesson or topic. Okay, I want to wish everyone a good day. Thanks again for attending.